Welcome to CE 402 Environmental Engineering 2 Module 5 Part 2. In this session, I'm going to discuss about the advantages of septic tank and the disposal of effluents from the septic tank. First one, the advantages of septic tank. As you all know, the septic tank can be constructed very easily and very little attention and skilled attendance is required for the operation of this septic tank. And the sludge is relatively small and most of it being liquefied and digested. The reduction in volume is about 60% and the reduction in weight is about 30%. So the removal frequency, that is the cleaning frequency, can be from 1 to 3 years. Then the cost is quite small and within the reach of the private householders. There is no moving parts for its operation. The effluent can be disposed of easily without much trouble. And when once installed, they give long carefree service. These are the main advantages of septic tank. Disadvantages of septic tank. The size required is large and uneconomical in the case of large quantity of sewage water. And the functioning and action is erratic. The effluent is dark and the foul smelling with a high BOD content when comparing to the influent also, often worse than the influent condition. And the leakages of gases from the top cause bad smell and environmental pollution also, and the periodic cleaning, removal and disposal of sludge is often tedious. Then disposal of the effluent from the septic tank. The effluent coming out from the septic tank contains large amount of putrescible organic matter, that is 200 to 250 milligram per liter, and its BOD is quite high, that is 100 to 200 milligram per liter. Although the sewage undergoes treatment in septic tank, the effluent may still contains pathogenic organisms, and hence septic tank effluents cannot be considered as safe for disposal onto the surface of the soil or onto the surface water or in the soil itself. The effluent coming from a tank will be malodorous and hence more objectionable than the liquid that goes into the tank. This does not mean that the tank has not purpose or value. Its primary purpose is to condition the sewage. That is, anaerobic action takes place, the most of the volume of the sludge is reduced, and it will less clog the dispersal field or make more amenable to other treatment. And the disposal of the effluent from the septic tank can be done in three methods, that is soil absorption system, biological filters and upflow anaerobic reactors or filters. First one is soil absorption system. This is the system adopted in most of the individual houses for the effluent, treating of effluent from the septic tank. It involves the disposal of effluent on the land and can be adopted only when the sufficient land is available. Also, the seepage capacity or the porosity of the sand or soil is great. That is, if the percolation rate not exceeding 60 minutes per centimeter, then we can use this soil absorption system. The percolation of soil or a ground is defined as the time in minutes required for the seepage of water through that ground by 1 centimeter. If the soil percolation rate is high, it means that the soil is less porous. This system can be accepted or designed for such a soil which has a high porosity. That is, the absorption capacity should be more. The sufficiently porous ground is not available. The effluent of the septic tank shall be subjected to a secondary treatment, either a biological treatment system, that is biological filtration system, or upflow anaerobic filter should be used for the treatment of effluent coming from the septic tank. And the soil absorption system may be following types. That is, first one, seepage pit or sock pit, and a dispersion trench. Normally, for individual houses, the seepage pits or sock pits are used. Sock pits or dispersion trenches are adopted in all porous soils where the percolation rate is below 25 minutes per centimeter and the water table is 180 centimeter or more from the ground level. Then the total subsurface area required for the sock pits or dispersion trenches is given by the following empirical relation. That is Q is equal to 130 root T, where Q is the maximum rate of effluent application in LPD, that is liters per day per meter square of leaching surface, and T is the standard percolation rate of the soil in minutes per centimeter. A sock pit is a circular covered pit through which the effluent is allowed to be soaked or absorbed onto the surrounding soil. The sock pits are of two types. First one is empty type. Second one is filled with coarse or this brick or stone aggregates. The first figure shows the sectional view of an empty sock pit. Here you can see the inlet pipe that is coming from the septic tank, which carries the effluent from the septic tank into the sock pit, which is located at a depth of 90 centimeter from the top of the uh, um, sock pit. This is provided to avoid the mosquito action, and this portion, that is the 90 centimeter depth, is covered with the plastic, cement plaster in order to avoid the mosquito action. And the brick lining with the dry joints are provided for the construction of the sock pit. And in order to enhance or accelerate the seepage action, extra lining of coarse aggregate with a thickness of 7.5 centimeter is given. And effluent water coming from the septic tank enters into the sock pit, and then it will seeps out through the soil surrounding the sock pit. This is an empty sock pit. The next figure shows the sock pit with a coarse aggregate, that is brick or stone aggregate filled as a filtering media. And here you can see brick lining with the mortar joints are provided at the top of this sock pit. And the inlet inlet pipe is provided at a depth of 30 centimeter from the top of the sock pit, and the total diameter of the sock pit is a minimum of 90 centimeter. And you can see the stone or brick aggregate filling inside the sock pit, and a brick chamber with a dry joints are provided for the protection of the inlet pipe inside the sock pit, and a 30 centimeter thick outer casing with a coarse sand is also given in order to accelerate the filtering action. That is, the coarser sand is provided, and coarser aggregates are provided inside the sock pit, and a wall of outer casing with the coarse sand also gives proper filtration of the effluent coming from the septic tank. This is the sock pits, two types of sock pits. Then disposal in absorption trenches. Septic tank effluent is allowed to enter in a masonry chamber called distribution box, from where it is uniformly distributed through an underground network of open jointed pipes into absorption trenches called dispersion trenches. The suspended organic matter present in the effluent will be absorbed in the absorption trenches, which are filled with gravel and well-graded aggregate. Clearer water will seep down the water table, and the plants surrounding this trench area will grow faster because of this water coming from the capillary action. And this is not recommended where fibrous roots plants are there in the location of these absorption trenches. then it will fail due to the entrance of these roots into the trenches and the open jointed pipes. It will block. Then it will only be adopted where the percolation rate not exceeding 60 minutes per centimeter. The dispersion trenches should be 50 to 100 centimeter deep and 30 to 100 centimeter wide, excavated at a slight gradient error till with a 15 to 25 centimeter of washed gravel and cursed stone. Open jointed pipe of unglazed earthenware or concrete are laid down and inside the trenches. The maximum internal diameter of these pipes should not more than 75 to 100 mm, and the dispersion trenches should not be placed closer than 1.8 meter. These pipes should be covered by 15 centimeter coarse aggregate, over which graded aggregates is filled up to 15 centimeter above the general ground level as shown in figure. This is the cross section of a dispersion system. Here you can see the cross section in the first figure. Below the ground level, the earthenware pipes you can see that is 70 to 100 mm diameter, and which is the chamber is filled with, that is the dispersion trench filled with a 15 centimeter coarse aggregate up to a depth of 15 centimeter, and a well graded aggregate or crushed stone aggregate is filled up to 1.5 to 2 meter, 15 to 25 centimeter, and you can see this is the cross section of a dispersion trench. Here is the plan view of a dispersion trench, that is the topmost figure. Here the distribution box you can see, that is from the septic tank, the effluent coming from septic tank is collected in the distribution box, and from this distribution box, through these earthenware open jointed pipes, earthenware pipes, unglazed pipes, this wastewater is carried into the trenches that is located parallelly at a minimum distance of 1.8 meter, and here you can see the pipes are open jointed, and this is filled with the filter media, and through these open joints the effluent water will enter into this filter media, and it will be seeped out through the filter media and into the soil. This is a dispersion trench. Then the biological filters, this is similar to trickling filters, and the effluent from the septic tank is sprayed on the filter surface through a rotary distributor, like in the case of trickling filters. The filtering media consists of coarse stones and maybe 0.9 meter to 1.4 meter thickness. Suitable microbial film is formed around the coarser media, which requires ample ventilation to get oxygen for biooxidation, that is an aerobic process. And to achieve this purpose, the under drains are connected to air vents situated at least 0.15 meter above the ground level. You can see the picture of these biological filters. First figure shows the plan of a biological filter. You can see the tank, the outer tank, and here the influent comes in the center part, and it will be distributed, and you can see the air vent pipes and the distribution channels are given for the even distribution of effluent onto the filter media. And the second figure shows the cross section across AA, that is you can see the slight slope at the bottom of the tank, in order to provide smooth entrance of this filtered water into the under drains, and it will be collected to a common place. and the air vent is provided in order to collect the these gases produced during the aerobic action. And you can see the third figure, that is section BB, and you can see the under drains are located at the bottom of this tank as small circles, and you can see the rotary arrangement at the top in order to provide the even distribution of effluents. And the air vents, you can see the under drain system, you can see the main collection part, that is the effluent or the treated water collection system, you can see in this figure. These are the three main sectional views, that is the plan, section 1 and section 2 of a rectangular biological filters. This works same as that of a trickling filter. This is a circular biological filter, same as that of the rectangular one, only the cross section, sorry, the plan view is circular. Then the upflow anaerobic filters. Effluent from the septic tank be successfully treated by using upflow filter in the form of secondary treatment. It is a submerged filter with a stone media that is 0.6 to 1.2 meter deep. Then the septic tank effluent is introduced it from the bottom. The microbial growth is retained at the stone media, making possible higher loading rate and efficient digestion. The capacity of the unit is 0.4 to 0.05 meter cube per capita, or 1/3 to 1/3 to half the liquid capacity of the septic tank it serves. The BOD removal efficiency is about 70%. The effluent is clean and free from odor and nuisance. This is a sectional view of an upflow filter, that is an aerobic filter. Here you can see two chambers, that is a cleaning chamber and a filter chamber. Filter material, that is stone materials, are provided at the second chamber, filter chamber, and this is encased with a total tank, and a removable slab will be constructed at the top of this tank, and the septic tank effluent will enter into the filter media through the bottom of the filter tank, filter area, and this will flow through this filter media, and it is collected from the effluent, that is the outlet. Then wire mesh support is provided, or perforated concrete block is provided to enter the effluent from the septic tank into the filter media. This is the sectional view of an upflow anaerobic filter. This table gives the recommended method of disposal of effluent of septic tanks. That is the position of subsoil water level, that is the groundwater level. If the groundwater level is less than or equal to 1.8 meter, then the porosity, that is the percolation rate, depending upon the percolation rate, if it is not exceeding 30 minutes, then dispersion trench can be located, and exceeding 30 minutes but not exceeding 60 minutes also, then also we can accept the dispersion trench. And dense and clayey soils with a percolation rate exceeding, that is the porosity with a high less porous soil, then the percolation rate will be high, then we can accept the biological filters. If the groundwater table is greater than 1.8 meter, then sock pits or dispersion trench can be accepted. And in the second case also, we can accept dispersion trench. And in the case of less porous soil, we can accept subsurface biological filters, or anaerobic filter, upflow anaerobic filter can be accepted for the treatment of septic tank effluent. I hope you understood the session. Thank you for listening. See you in the next session.